Hello students and teachers. In today's session, we are going to make RFID, that is radio frequency identification, door lock automation using Arduino board. You might have heard about RFID, but we will learn in details about what RFID is, how to use this mechanism or this technology for door lock automation. We have been using different locks to secure our homes or schools or different premises. So let's talk about locks in more details, their history and their types. So human beings, from long time since modern civilization, our ancestors developed, something to keep their belongings to themselves. So initially they were simple knots made using rope or some other mechanisms. But wooden and metal locks started in use. Different cultures like Egypt, Greek, or Roman started developing these type of wooden and metal locks. We can see them in around us nowadays. So let's see types of locks. So first are padlocks. These are mostly available with us. They cannot be attached permanently to anything. You can remove them and keep them aside. You can lock them. You can put them into the latch when you're going to lock them. There are two types of this. Basically, combination, which is a number lock, and there is a keypad. So combination lock has one or more numbers to dial, and then keypad locks are of different types like rekeyable and non-rekeyable. So these are padlocks. Then comes the deadbolts. These are basically installed on the external doors. You might have seen nowadays every apartment, every home have these deadbolts on the external door, which are like single, double, or triple thumb turn. Basically, they are having a problem that in case of emergency, if you forget the keys inside, it is difficult to open the lock from outside. So that is the only challenge with these type of locks, but they are more secure compared to the padlocks. Now, the third types of locks are lever handle locks. They are easily you can see them on the bathrooms or doors inside the house. They are easier to open, a simple knob or some kind of lever mechanism, and they can easily, you can push them, you can easily pull them to open. So basically, handicap accessibility is important, and which is achievable from this lever type of locks. They also come with keys. Now, smart locks nowadays, without doubt, they are of most convenient to each other, to each one of us. These gadgets are installed on the entrance. Basically, they are electronic and smart locks. The advantage is, they only permit authorized individuals. Security standards can be put into place according to our needs, and they can't be easily tampered or damaged, with anything else, similar to latches or keys. So those are smart locks. Types of electronics or smart locks are like RFID card lock, which opens with the radio frequency identification card, which we are going to make in today's session. The second type is biometric reader, which reads your thumbprints and fingerprints. And the last one is like smart locks. Basically, they are opened and locked using the applications on your smartphones. So they are of these type of electronic locks are most convenient nowadays, and we are going to make one RFID card lock for our purpose in today's session. So this is how we are going to make the RFID card lock. The box contains all the electronics. The blue component that you can see on the box is RFID card reader, and the one that you can see on the floor, yellow and blue, are basically 3D printed lock mechanism that we have printed on our 3D printer. It also has the servo motor. Now let's see basically what all about the RFID, radio frequency identification. So RFID technology relies on radio waves. First important point to know. It basically receives information between a tag and a reader. So there needs to be a tag and there needs to be a reader. So the RFID reader sends a signal to the tag or card, and the card or tag sends the information back to the RFID. It consists of three components: a scanning antenna, a transponder, and transceiver. So these are the three components of RFID. So main types of RFID tags are active RFID. Basically, they have their own power source like battery, and the passive RFID, which basically receives its power from the reading antenna, that is external power source, whose electromagnetic wave induces a current into the RFID tags antenna. So these are two RFID tags, types of two RFID tags, uh, and you can see them. Now, let's see some common uses of RFID application. So basically, you can track pets and livestock, inventory management in big warehouses and store. You can also track your assets, equipments like cupboards or all the equipments in your school. Then cargo and supply chain logistics, where my truck carrying the supply chain or material is. Nowadays, vehicles are also tracked, FASTag, then healthcare, manufacturing, retail sales for purchasing the products, and credit cards also. Now, difference between RFID and barcodes. You might have seen barcodes. The reference link for detail is given in the QR code. You can scan the QR code and read more about this slide on YouTube. So RFID is basically can identify individual objects without direct sight, and barcode needs direct scanning. RFID needs power source, barcodes need no power source. So you can read them the differences in detail later. But yes, so RFID module or RFID system works on these different components. The first one is RFID card reader, which you can see on the top, which is a blue card. It has a different pins on it. We will see the different pinouts on the RFID card later. The bottom ones, the left one on the bottom, which looks like keychain, blue keychain, is RFID tag. On the one on the right hand side is RFID card. So both of them have smart chips and information stored in them. Now the RFIDs are also used in FASTag. So basically, it is used to collect the toll electronically on the highways. So basically, it enables the cashless toll collection. So RFID tag basically has electronic information about the vehicle. So electronic produce code is what it is called as, and it has 13-digit EPC code. So each vehicle receives a unique customer ID while they pass through the toll gate, and that's how the radio frequency signal from the reader and the RFID scanner can track the payment information. So as the vehicle comes, it basically the antenna has the microchip in the RFID tag, which contains and the RFID FASTag has all the information like expiry date, payment. So the reader sends small radio frequency signal to track the data, and the tag catches the signal from the reader, and it basically exchanges the information, and that is how the entire payment happens digitally and contactless. So the traffic is less on such toll booths on the highways. You might have seen and experienced these nowadays all across the highways. Now let's see, let's make our own RFID lock. This is how our RFID card lock looks like after we have packaged them. All the components are packaged inside a cardboard box, that's white cardboard box, and this is how our final product will look like. Before we package all the components, the system will look like this. So we have used the breadboard, the RFID card, the jumper cables, Arduino Uno board, then the Arduino Uno cable, and the lock mechanism that we have 3D printed. And we also are using LEDs, green and red LED, buzzer, and the servo motor. So this is how our system looks like before packaging. Now let's go to the circuit diagram quickly. We are going to refer it in detail while we are going to make the circuit in detail in this session. But more or less, you can pause the video later and look into the circuit diagram. It is very easy. We are going to connect the RFID card first to the Arduino board. Then we are going to make connections between the breadboard and Arduino board, including the LEDs, buzzer, and the servo motor. And as you know that we are also going to upload the Arduino code into the Arduino Uno board using Arduino IDE. The details of the code are also given in the later part of this video or this session. So this is a circuit diagram. You can always pause and refer to this. Now RFID card pinout. So this is RFID card. So you can see all the pins right from top to bottom. I'll read. The first one on the top is SDA. Second one is SCK. Then MOSI, MOSI. The fourth pin is MISO. We are not going to use that IRQ pin, which is interrupt pin. We are not going to use in this project. Then the next bottom three pins are ground, that is black. Yellow one is reset pin, and the red one, the pin at the very bottom, is VCC. So these pins are required. Now we are also using a servo motor. So a servo motor is basically a rotary actuator or a linear actuator. Basically, it allows precise control of angular position of the motor. Linear, angular and linear position, velocity and acceleration, they are all controlled precisely, and it is coupled with a sensor. Basically, other motors don't have a sensor. This motor has a sensor inside. So this sensor gives a feedback in terms of the position feedback, and the motor adjusts its position correctly. The three pins that comes out of motor are basically brown one, so that's a signal pin. The red one, which is power pin, plus 5 volt, and the orange one is the orange one is signal pin, and the brown one is ground pin. So ground wire. Now, let's see what are the parts and tools required for this project. I already have mentioned this, but we are going to need the hot glue gun, 12 volt DC battery, then vernier caliper, the long nose plier, paper cutter, small screwdriver, or you can call it a tester. Then we are also going to use the removable bench vise, the cutting mat. We have 3D printed gear and door lock mechanism. We are also going to share with you in this video the source of the 3D printed file. So you can scan this QR code. You can pause this video. You can scan this QR code using the QR code scanner app on your mobiles and download the STL file of this mechanism. So you can directly print. You don't need to design this part. The only thing that you need to take care is the original model is designed for the bigger servo motors, but the SG90 servo motor that all our labs have is small, and you need to reduce the model size to 60% before you print it. Now, the electronic components that are needed are Arduino board, RFID card reader, then RFID card, one green LED, red LED buzzer, servo motor, breadboard, male to female jumper cables. You can use the jumper cables as per the color coding in the circuit diagram. It is not mandatory, but it is easy to recognize and differentiate between different jumper cables. And definitely you need the Arduino USB cable to transfer the code and also the power. So these are all the electronic parts that are needed for this project. Now let's start making the RFID card connections. So using the jumper cable. Now this is a RFID card pinout we have seen. On the rightmost side is SDA, SCK, and like that it goes up to 3.3 volt on the leftmost side. So as per the circuit diagram shown in the earlier picture, as well as there is a picture in the bottom corner of this video, we are connecting all the pins. So a blue jumper cable for SDA, and we are just trying to match the colors of the jumper cables the same as that of the circuit diagram, so it is easy for us to later make connections. Only in this case we don't have the red wire, that is the fourth wire that we are connecting now. We didn't have, so we are just using the same color wire for the miso pin, but that's okay. You can always you can always use the red one, and also check if there is any confusion. You can always check which wire is coming out of which pin. So yeah, we didn't have a red one that he just highlighted. Now we are going to take a black cable and connect ground pin on the RFID card. So that's a black pin connected to the ground. Now we are going to use the purple pin for the so we are going to use that purple pin for the second last pin, and the red pin for 3.3 volt positive supply, 3.3 volt positive supply. So we have made all the connections on the RFID card. So now we will show you all these 7 pins that we have connected. One pin has to be left empty, so that is there is no connection. So this is how basically the RFID card connection looks like. So the purple pin is connected to reset pin, yes. Now, connection of RFID card to Arduino. Let's make that connection as per the circuit diagram shown in the bottom right. So right now I'm not going to call out the pin numbers, but yes, the blue wire is connected to pin number 10. The green wire is connected to pin number 13. Now this pin is connected to digital pin number 11 on Arduino, and this pin is connected to digital pin number 12 on the board. So these four pins are connected on Arduino, and now let us connect the reset pin, that is this purple pin, reset pin on the RFID card, to digital pin number 9 on Arduino. That's purple pin is connected to pin number 9. Now let's take the red jumper cable, that is the positive connection, and the black cable, that is the ground connection. So put this black cable on one of the ground pins on Arduino board. Now this red pin is connected to 3.3 volt, not on 5 volt. So 3.3 volt pin on the Arduino. So this is done. Now let's connect LEDs, buzzer and servo motor to our circuit. So now, first of all, let's put this green pin for LED on pin number 5. Now, this one for red LED. All these are like signal pins. You can find those into the code. So now this yellow pin is for signal pin for servo motor. Now these four pins are connected. Now let's put the buzzer. Let's check the positive port. The buzzer has anode and cathode. So let's check which leg is cathode or which leg is anode, plus and minus. Now insert the buzzer into the breadboard. Now a red LED, the green LED will put first. Check positive and negative connection of the LED. Same thing for the red LED. So positive port on the leftmost side, or you can check the circuit diagram and put appropriately. Now the LED buzzer are assembled. Now give the signal connection for green LED, that is green wire, red wire to the signal pin for red LED. This purple pin is the signal pin for buzzer. Actually, I mentioned it for servo motor, but this is for buzzer. And the yellow one, yeah, now which one he's holding? The yellow one is basically a signal pin for servo motor. So now let's take SG90. You can use metal or plastic geared servo motor, doesn't matter, but it should be small one, SG. It need not be MG, you know. So let's take servo motor, put the yellow wire into the signal pin. So that is orange color pin. Now let's make common ground connection. Connect this black wire on second ground port or pin on Arduino, and put this into the breadboard. So we are going to give this as a common ground connection, ground pin to buzzer, LEDs and servo motor. So now let's take four wires, mostly gray and black you can use, just to differentiate them as ground pins. Now first ground pin, ground connection to buzzer. Tighten the buzzer into the breadboard properly so that it receives signal. If it should not be hanging into the air. So second ground connection is given to the green LED. Same thing now. Third ground connection, we are going to give it to the red LED, and last ground connection, one more ground connection from the common ground port to the servo motors, ground pin. So which is dark brown. So now, as per what we have shown here, connect that to the brown pin on the servo motor. So now the only pin that is remaining to be connected is the positive 5 volt. Now connect this red cable to 5 volt pin on the Arduino. So this 5 volt pin is connected. This jumper cable is connected to the 5 volt pin on Arduino, and this is connected. This red cable 5 volt is now given to the servo motor positive pin. So now servo motor, all three cables are connected. Signal pin, then ground pin is already connected. Now the middle orange pin of servo motor is connected to the 5 volt ground pin from the Arduino. So all the connections are done on LED, buzzer, servo motor, RFID card. All the circuit connections are done as per circuit diagram. See, this is how it looks like. Now let's upload the Arduino code. So before we do that, connect our system to the computer through USB cable. Now, before we upload the main code, we need to install one library, and we also need to identify the RFID card. So for that, let's first install the library. Connection Arduino, select the port, go to Tools and Manage Library. Search this library MFRC 522 and install this particular library MFRC by install this library. Once this is installed, you can use this library into the code. Minimize that, delete this by default code, go to examples, the bottommost MFRC52 and dump info. Select that code. You will the new window will open with the code. So this code is needed to basically find out the RFID unique code. So each RFID card has a unique code. So this is a code, this is a standard code. We don't change anything. Just open the serial monitor just to see. Then compile and upload this code to Arduino. This is not a main program, but this is a program that is needed before we actually put the RFID card number into the main code. So go to serial monitor. There is some technical glitch of Arduino IDE, but yes, go to the serial monitor and put the card in front of the RFID reader so that it will pick up the RFID card number. In this case, the one that is highlighted is RFID card number. We need, you note down this number, we need this RFID card number to be added to the main code. So now let's upload the main Arduino code. So this code is actually primary code. You can use this QR code and your QR code scanner from your mobile to download this code, and you need to adjust the code as per your RFID card number and also as per the lock dimension, whether you need to turn the lock 60 degree or what. Now connect the Arduino board, select the port. This code basically has this library of RFID card servo.h. These both libraries are important. Now pins are defined, LED green and red pin, then buzzer pins are defined, and also the RFID card pins are also defined earlier. In void setup, this is standard code. I'm just highlighting the important ones. Void setup define the output pins, LED, buzzer, and RFID, and then serial print, put your card to the reader. In void loop, what we are going to do is basically we are going to see if there is a new card available to the reader. When the user put the card in front of the reader, it should identify whether there is a new card being read. So the next part of the code is basically it serial prints the tag, the card tag. So this is the code. This is the card number that we just found out in the earlier code. We added this card number here in the main code, and then if the card reader identifies this card, the right card comes in front of the reader, the LED green LED will turn high, the green LED will turn on, and the buzzer will turn on. If now in the else part of the code, and then there is a delay. Basically, this delay you can give 10 seconds after the lock is opened for user to enter the door. So if the wrong card is given next to the reader, it says access denied. Okay. So this code is written. You can verify the code as per its if it is correct syntax or not. And sometimes accidentally we delete something and make some mistakes. Now the code is being uploaded. It is uploaded already, and now let's do initial trials of the mechanism. We have uploaded the code, we have made the connections. Now let's put the card in front of the right card in front of the reader. LED turns, green LED turns on, the motor revolves for 60 degree. We just put 60 degree in front of the code. We are making different trials, whether it is, so it will unlock and relock. So let's see, if the right card is put next to the reader, it will show the card number and authorized access. So it identifies. You need to open the serial monitor from the Arduino and see that whether the right card is put and authorized access is given. Now let's do the lock mechanism assembly that we have 3D printed. So measure the shaft diameter of servo motor, so which is 4.8 millimeters. We need to have the right hole size on the gear. So let's take approximately 4.5 mm diameter drill, put that into the drilling machine, hold the gear that we 3D printed onto the bench wise, tight it securely so that it doesn't slip, and then make the drill at the center. There is a already 3D printed hole, but now let's take some extra sharp edges out of the 3D printed parts just to make sure that all the edges are smooth and there is no burr, so that our mechanism works smoothly. Use paper cutter if needed to remove the extra sharp edges. Since the 3D printed parts are secured onto the 3D printed 3D printer table, the base plate, so it needs to it usually has those edges. So take out those sharp edges on all the parts using paper cutter, and if needed, long nose plier. Make sure that you are using the safety gloves, in so that you don't accidentally cut your fingers or hurt yourself. So all the parts are clean and smoothened. Now assemble the servo motor onto this mechanism. Use hot glue gun. Carefully apply the hot glue all around the motor into this slot, so that the motor is securely tightened into the mechanism. So this is our latch mechanism, which is going to be installed onto the door. Now turn around the mechanism if needed, and apply the hot glue on all other sides. Use a good amount of hot glue so that the mechanism is secured and tightened properly. So this assembly is done. Now assemble the gears as well, and let's do trial before we actually do system packaging. Okay. Now this is the final system. Yes, the door is opened and again locked once the user gets into the room. Opened, locks. So the door is opened for a few seconds. The user gets into the hall or the room, and the door locks again. So this is how it will show onto the serial monitor. Authorized access. If the right card is put in front of the reader, authorized access is given. Now let's try using some wrong card. Red LED will turn on, and the buzzer will also turn longer, and the lock mechanism doesn't move, and wrong access denied is shown onto the serial monitor. Now let's do final packaging of project. You need to make a final packaging. So let's take one cardboard box, make this drill for Arduino out. This another these two holes for RFID pins. So put the RFID card with all the pins through that hole, and then breadboard with all the connections. We have already put the Arduino board onto the bottom part of that box. And then LEDs, we need to, turn the LED terminals, or, twist the LED terminals. We are going to make two holes onto that box. There is a power jack. It looks like you can 3D print as well. This is how our final testing of our product looks like after we have packaging and everything done. Put the right card in front of the reader. Green LED turns on, the door is opened, again locked. I will show it again. Right card is put, green LED, door is opened, and again locks. The delay is given for user to enter. The wrong card is given, the red LED turns on, and the door doesn't open. So this is how our final product worked beautifully. Do you have any questions on this particular project? You have learned how to use RFID card. You started with learning basics of RFID, where RFID card, RFID technology is used in different areas like retail, vehicle tracking, healthcare, then safety and everything. Any questions? I'm available on the channel. You can post your questions there. Thank you for watching this video. I'm sure you learned a lot of things into this session, and you are going to make one project using RFID card. You can also use RFID card Arduino to track attendance. Once you enter your school, the attendance is tracked, or in any office, attendance can be tracked using RFID. Thank you very much.